Let us understand the bisection method. Let us state one theorem that we already know, or it is easy to understand. It says like this: if a continuous function f of x is the property that fa multiply fb less than 0, or say some ab real number a less than b, then fx has a root, or you can say has a solution in the interval AB. Bisection method works on this theorem. So let us explain or understand what is the bisection method. So you are given a continuous function f. It may be algebraic or it may be transcendental, or it may be transcendental, like x square minus x minus 3, or like x sin x minus e power x kind of things. So you are given a function, continuous function, and need to find a root of fx equal to 0, or you can say solution. That means we need to find out the value of x for which fx is equal to 0. We need to find out the value of x for which f of x is 0. So first step is like this: find a b such that fa multiply fb negative. That means it means that fa and fb are of opposite sign. Fa and fb are of opposite sign. Say fa less than 0 and fb greater than 0. It may be fa greater than 0 and fb less than 0. That is also. So now because of that theorem, there is a root in the interval a to b. So it's like this: like this. Say here a and here say b. So you can see that fa, this point is afa, this point is bfb, and this is our exact root. There is at least one root. It may have more than one root, like this. Like here somewhere A, here somewhere B. So you can see that there are more than one root. But there is one root is guaranteed because of the function is continuous. So this is our exact root. And we would like to find out very much near to this exact root. We call it as approximate root. So here we say that there is a root in the interval AB. There is a root in the interval AB. Now, what we do is that as a first iteration, we do like this. So we like say x1, this is midpoint of A and B. That is A x1 equal to A plus B by 2. So we find x1 as A plus B by 2. Now we need to check f of x1. So suppose here you are having x1, okay, that is the midpoint of A and B. So f of x1 we need to check. So suppose in our case fa less than 0, fb greater than 0, like this. Now we need to find f of x1. So it may be equal to 0, it may be greater than 0, it may be less than 0. So if it is equal to 0, then x1 is exact root. But normally we don't have that kind of thing. So this will not have, because we are going to find out the approximate root. Now it may be greater than 0, it may be less than 0. So if it is greater than 0, say in our case, what happened? If it is greater than 0, then so like this. So now you can see that the root lies in a to x1. Okay. So if it is greater than 0, and in our case fa is less than 0, then you can say that root lies in a to x1. And if it is less than 0, then you can see that fb is positive, fx1 less than 0, then you can say that root lies in x1 to b. Okay, so either you have this one or you have this one. And next step, continue the process like x2. So if it is this one, then you find out a plus x1 by 2. If it is this one, then you find out x2 as x1 plus b by 2. And again continue the process by finding fx2 and check where the root lies. Okay, so suppose in this case, suppose say x2 is here, suppose. Then there is a root in a to x1, a to x2. So that way we need to continue the process. We need to continue the process until we get like f of xi is very much near to 0, not exactly 0 but very much near to 0, or you can say that continue until some desired places of decimal, it will be given in your question, or continue until below some percentage error, below some percentage error. So that is the way the bisection method works. We can take one example. Okay, let us take one example. Find a positive root of an equation x cubed minus x minus 1 equal to 0 using bisection method, and let us take say correct up to 2 decimal places. Correct up to 2 decimal places. Now let us see f of x is x cubed minus x minus 1. That is given a positive root. So let us begin like this. F of 0. So let we first find a and b such that fa and fb are of opposite sign. So f of 0 is minus 1, negative. Then let us take f of 1. So that is also minus 1, which is negative. Then find f of 2, and you just put it here 2. So 2 cube minus 2 minus 1. So it is 5. So it is positive. That means, see, f1 is negative, f2 is positive. So you can say that there is a root in the interval 1 to 2. There is a root in the interval 1 to 2. Now you can do like this for the iteration. You can prepare the table also, like a, b, then excise a plus b by 2, and then f of xi. Okay, so you can do like this. So here a is 1 and b is 2, and at 1 the fa is negative. Okay, this is only you need to take care. Fa is negative. So at 1 I write like this, negative, and fb is positive. That means f2 is positive. The meaning here is f1 negative. The meaning here is f2 positive. So the xi is nothing but 1 plus 2 by 2, and that is nothing but 1.5. Now you find f of 1.5. So you are having the function fx is x cubed minus x minus 1. Use the calculator and you can see that f of 1.5 is 0.875, and that is positive. So here you write positive. Okay, f of 1.5 is positive. Now see, 1.5 to avsich. 1.5 is definitely there in the next step. Now what is the another thing? Either 1 or 2. So this is positive. F of 1.5 is positive and F1 is negative. So now the root lies between what? 1 and 1.5. F1 is negative. F of 1.5 is positive. Okay. Root lies between negative positive or positive negative. So here positive say. So here now this is also positive. So this we don't need to take. This is negative. So root lies between 1 and 1.5. So next is you need to find 1 plus 1.5 by 2. And that is nothing but 1.25. Now you find the value of 1.25, value of the function at 1.25. And we see that it is, use the calculator, you will find minus 0.29688. That means it is negative. So at 1.25, it is negative. So now next step, AB we need to select. 1.25 to sure us. 1.25 definitely will be there. So now we need to check either 1 or 1.5, any one of them. So what is 1.5? 1.5 is positive and 1 is negative. At 1, it is negative. So this is at negative, this one is positive. The value of the function, okay, not 1 or not 1.5. I am writing this to make you understand value of the function. F of 1.5 positive, f of 1 negative. Okay, this meaning f of 1 negative, f of 1.5 positive, 1.25 negative. So now the root lies between negative positive. So it is between 1.25 and 1.5. So now here you will have 1.25 and 1.5, 1.25 and 1.5. So find the mid value between these two. You can find out 1.5, 1.25 plus 1.5 by 2, and then you will get 1.375, and 1.375 you find out f of 1.375. Use the calculator and you will see that it is 0.22461. That means at this point the value of the function is positive. Okay, this is at 1.5 positive, at 1.25 negative. Now 1.375 definitely will be there. So we need to select either 1.25 or 1.5. So this one is positive, 1.25 is negative. So now the root lies between 1.25 and 1.375. Okay, and now find the midpoint of 1.25, 1.375. That means 1.25 plus 1.375 by 2. That you will get 1.3125, and then find the value f of 1.3125. So f of 1.3125 is minus 0.05151. So that is negative. This is negative. So at this point, the value is negative. At 1.375, the value is positive. Function value of the function is positive, and 1.25 is negative. Now this is also negative. So now what does it mean? The root lies between where to where? 1.3125, that is value of the function is negative, and 1.375 value of the function at this point positive. Now find the midpoint of these two, 1.3125, 1.375. You will get 1.34375, 1.34375, and then find out the value at 1.34375. So f of 1.34375 is 0.08261. Verify from the calculator, it is positive. So this value is positive. Okay, this one is positive, the value of the function. This one is 1.3125. At 1.3125 it is negative. Okay, so then next step is next step is we need to check which point. This point will definitely there. આ point તો હોવાનું છે. હવે સિલેક્ટ કરવાનું છે, કાં તો આ છે 1.3125 or 1.375. Now this is positive, this is also positive, so this definitely not there, this one is there. So 1.3125, which is negative, at that point the value of the function is negative, and this one is positive, so 1.34375. And now find the midpoint. 1.3125 plus 1.34375 divide by 2, so we'll get 1.32812. Use the calculator. 1 point, value of the function at 1.32812 is 0.01458. Now you can see that now the value is 0.01. So we are now approaching near our answer. The value is positive. So here the value is positive. So now there is a root between where this point will definitely there, it is positive. 1.34375 is also positive. Value here is positive. 1.3125 is negative. So now again the root lies between 1.3125 and 1.32812. So find the midpoint of these two, 1.3125 and 1.32812. You will get 1.32031. Okay, and now you can see that the two decimal digits like these two approaching means equal, so we can even find the value at f of 1.32031, and that is nothing but the use the calculator, and that is nothing but negative minus 0.01871, and it is negative. Okay, so at this point that is negative. If you want, you can go one more step, otherwise you can declare your answer, that is 1.32031 or 1.32, because it is between it, you need approximation up to two decimal digits. So next step, if you want one more step, even though it is not required, you can have one more step. So now the root lies between where? So this is positive. 1.32812 is positive. This one is negative. So now the root lies between 1.32031, okay, and 1.32812. and find the midpoint of this. Add these two and divide by 2. So then you will get 1.32422. Okay, and you can see that the approximate root, you can declare that approximate root is 1.32 because it should be correct up to 2 decimal digits. Thank you.